So we've got a rocket flying up at 35 meters per second, 25 degrees to the horizontal. We've got a sniper trying to take this guy out. And his elevator, for some reason, is an elevator where he can somehow control the speed of. And the elevator is, he needs to control the speed so he's always in line with this rocket, and the rocket is not dropping below or above, and he's controlling it to be in line with that rocket. Meanwhile, the person in the rocket has got a little friend who's in a car, and he's got to stay directly underneath him so as the person can jump out of the rocket and land in the car safely. So how do we solve this problem? Well, basically, the car is traveling at the same speed as the rocket as the rocket's horizontal components. The rocket's horizontal component, and the elevator is traveling at the same speed as the rocket's vertical component. In other words, we're going to separate this rocket's velocity into its components using a little bit of trigonometry. So we can draw the line, we can draw a triangle like this, and that would be Vx, that would be Vy. Vx is going to be the speed of the car, Vy is going to be the speed of the elevator. This would, I drew the 5 before the 3. That would be the speed of the rocket. And then the angle would be 25. So the opposite, which is Vy, the speed of the elevator, is going to be equal to 35 sine 25. Vx is going to be equal to 35 cos 25. By typing those into my calculator. So the horizontal, and now we can also see that this is probably about right. We can see that the horizontal component, because this is a relatively small angle, is going to be reasonably close to 35 meters per second, but not quite as fast as that. So 31 seems about right. And this is going to be the vertical component is going to be a little bit smaller because of that angle's a bit smaller, and this angle over here would be larger. So the person in the rocket would be going at 14.8. Sorry, the person in the elevator would be going at 14.8 meters per second, and the person in the car would be going at 31.72 or 31.7 meters per second. I'm not going to go too much into. I'll briefly mention something about how many decimal places, how many significant figures I should use. So really, I should actually only use 3, maximum of 3. The data that I've got is in 2 significant figures. I'm allowed to give up to 1 more significant figure after that. I won't go into the reason why that is at this stage, but so this is 14.8 meters per second and 31.7 meters per second. Okay.